And now, the analysis procedure.
Open Mac1 Analysis software and open the folder path containing the torsion test result files. From the file list, select the result file from the torsion of wood and select the move relative function. Choose the torque in the z direction as the vertical axis and position theta as the horizontal axis. From the Analysis drop-down menu list, select Slope. Use the cursors to select the first linear region of the curve which corresponds to the elastic region. It is also possible to zoom in the curve in order to have a better look at the linearity of the curve. Report the slope, which corresponds to the torsional stiffness of the sample. Now let's analyze the torsion of the bone, which is a rat femur. Select the move relative function, and we will zoom in the curve and position the cursors to select the first linear portion of the curve, which corresponds to the elastic region of the sample. We will zoom in once more to ensure the linearity of our selected region. So report the slope, which is the torsional stiffness of the rat femur.
The slope obtained from the analysis corresponds to the torsional stiffness of the sample. In order to obtain intrinsic mechanical properties resulting from the torsion test, the sample's shape and dimensions need to be considered. For a circular section, the polar moment of inertia is calculated as shown, while for a tube section, it is calculated as shown. Use the following equation involving the slope, the gauge length, and the polar moment of inertia to obtain the shear modulus. Using the parameters of the sample, such as the diameter, the gauge length, and the wall thickness for a tube section sample, calculate the shear stress and shear strain from the torque and rotational displacement data. Let's consider the data from the torsion test of the birch wood sample, the diameter being 3.1 millimeters and the gauge length being 15 millimeters. Here is the shear stress, shear strain curve of the birch wood sample. And now, the data from the torsion test of the rat femur sample, the diameter being 3.4 millimeters, the cortical wall thickness being 0.75 millimeter, and the gauge length being 13 millimeters. Here is the shear stress, shear strain curve of the rat femur sample.